In this video, we are going to go over how to find the slope of a line given a line on a graph. Let's talk about what slope is. Let's dive right into it. Let's do it. This is a big deal. Find the slope of the line are our instructions. Now, what I have here before we get into the graph is we are told that the slope is equal to the vertical change divided by the horizontal change of a line. That is basically like saying how steep is a line, and to figure out the steepness of a line or anything, we look at how much we go up compared to, with division, how much we go over. In math speak, a little less formally, we call that rise over run. A lot of people will also look at this as the change in the y direction over the change in the x direction. That's it. That gives you the steepness. Very cool stuff, and in later videos we'll connect this to a very cool formula. But for now, let's just get used to finding the slope of a line. So I will show you how to find the slope of this line using the idea of rise over run. Then in the second bit of this video, I'll show you how to find maybe another slope of another line or two. So a little bit of bonus coverage here or there. It doesn't take too long and you're gonna rock it. Let's do it together. So, rise over run. Well, to figure out the rise over run of a line or the slope, you want to pick points that are on the line that cross really nice, what I like to call intersections on the graph. So they cross at nice points. So this would not be such a nice point because we're not really sure, even though it's over 2, we're not really sure what the y value is. However, a point here or here or here or here are all nice points. So it does not matter which points you choose because we're going to be consistently going up and over the same amount. So I'm going to pick these 2 points right here. What I like to do when I'm first teaching this, or when I first learned it, and when students first learn it, is to draw in like a little dotted triangle here, basically. So I'm going to make dotted lines that connect the motion of over and up or up and over of these 2 points. Then I count how much this changes, because that would be my vertical change or my rise. And then this would be my run, how far over I go. So that went up 1, 2, 3. So that is positive 3 because as we go over to the right, we've gone up 3. Now, as we go over to the right, we go over 1, 2 blocks. To be very specific, we're not counting how many points we go from. So it's not like you start here and say 1. You're saying how many blocks there are. So it's 1 space, 2 spaces. So the slope is now the rise over the run. Well, the rise over the run in this case is up 3 and over 2. Now, some people might say, what happens if I go in the opposite direction? What happens if I go down 3 and left 2? Well, that's fine as well. If you were to go down 3, we would have a change in the negative direction. That would be down 3, left 2. Well, that would be negative 2, and a negative divided by a negative is a positive. So that still symbolizes that we've gone up 3 over 2 in the long haul. We typically read graphs from left to right. That's how I do things to stay consistent, but you could go right to left. What we do not do, ever, we don't go up 3, left 2. Because you're not on the line, right? You're not actually doing the motion of the line. So either go down 3, left 2 to start on the line and finish on it, or up 3, right 2. It's your call. Just remember it's rise over run for steepness. And one other point is it doesn't matter what points you pick on the line because we're taking that consistent path of up 3 over 2. For instance, let's say that we start at this point down here and we go all the way up to that point. Well, here we've gone up 1, 2, 3, 4, 5, 6. So that's up 6, positive 6, and we've gone to the right 1, 2, 3, 4. Well, that would be a ratio, a rise over run of 6 over 4, which if you simplify that with the greatest common factor of 2, you will get 3 over 2. So the slope of that line is 3/2. It tells you how you move from one point to get to later points on the graph. And that, my friends, is super awesome. Slope! On the other side of this video, as promised, you will see an example or 2 more just to get into the groove of how to find the slopes of lines. And here we are on the other side of the video with some bonus coverage of how to find slope. I figured I would give you a line now that is going down to the right to see that that will have a negative slope. Let's check it out. So again, as I mentioned in the beginning of the video, you want to pick 2 points that are nice points, where they're clear what the values are. So I've given you what these points are. You could pick this one, this one, this one, or this one. So let's go from this point to this one. I tend to go as close to 2 consecutive nice points as I can to make as accurate of a measurement of slope as I can. So remember, slope is the rise or change in the y value over the run or change of the x value. So I look at this and I'm going to draw a little dotted line here and a little dotted line over like that. I have gone down 1, 2. So if I go down, I put a negative 2 because from this point to that point I have gone down 2. That's a loss of 2 in height. From this point on, we go over 1, 2, 3, 4, 5. So that is a change of positive 5. I've gone to the right 5. Rise over run would be down 2 for every 5 we go over. And that's our slope. That's it. You could have picked other points. We could have gone from this point to that one. We would have gone down 1, 2, 3, 4, and over 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. Down 4, left 4 over 10 is the same fraction as down to right 5. Very cool stuff. We're going to do one more line, just one more, just to make sure that we've got this thing down well. But hopefully now you've seen a positive slope and a negative slope. You realize that as we go from left to right, if we're going down, we have a negative slope. We are losing y value as we go in the positive x direction. In the previous part of this video, as we went up, we went to the right, we went up, I guess you could say. So as we went to the right, we went up, causing a positive slope. Let's check out one more example just to lock it in if you need it. Otherwise, it's been real fun. You know how to find the slope of the graph of a line. Stay tuned for bonus coverage if needed. And here we are on the other side of the video, a third side, my goodness. To do one more slope problem when given a graph, I figured I'd give you a slightly steeper slope and see that we can deal with slopes even if they don't end up being fractions with denominators other than 1. Because the last 2 examples have had fractions with a denominator of, well, 2, and the other one had a denominator of 5. No problems, let's do this. So again, slope is the change in the y value over the change in the x, which is the rise over the run. We'll pick 2 nice points. Here's one and here's another. So we will move to the right, 1, 2, and it looks like we go up 1, 2, 3, 4. A lot of people, by the way, count it this way. They'll go 1, 2, and kind of make bubbles, and then write down a positive 2, and then go up 1, 2. We go 1, 2, like so. 3, 4. Just to help with their counting, that's up to you if you do it that way or not. Point being is we've gone over 2, up 4, that's a rise of 4 for a run of 2, which simplifies to 2 over 1. Now you could write that in simplest form as a slope of 2, but know that that implies that there is a 1 underneath and that for every 2 we go in the y direction, we've gone over 1 in the x direction. Very cool stuff. So a slope where the denominator is 1, it's all good. Slope is rise over run. And in the not too distant future, we're going to see how to find the slope of a line when we're just given 2 points that are on the line, but we're not given the visual of it. Can't wait for you to check that out. It'll match perfectly with this idea right here of rise over run.